Hello everyone. In this second episode, I will be talking about the 4 different flows that exist in OAuth2. So let's start first. What is the problem? The main idea is that OAuth2 lets apps access data on your behalf, meaning that there is some data and you need some apps to access this data like if it was you, but you don't want to provide constantly your username and password. So you have to kind of delegate this and give something that replaces your username and password. It's like when you want to take a trip on a plane, you don't have to always provide your identification card. Say, okay, I'm Jose, okay, I'm Anthony, okay, I'm Marie. You don't have to do that. You show it once, then they give you a ticket, and they trust the ticket every time you are inside the airport. Of course, sometimes in specific sensible place, they can ask you again for your identification card, but most of the time your ticket is enough. So this ticket, it's the proof that you are you without you showing constantly your photo and your personal data using an identification card. That's the main idea behind OAuth2. But the question here is that not every app, user or device is the same. Sometimes you want a machine to talk to with another machine. So there is no possibility to use a username and password. You say, okay, there is, yeah, in the legacy systems, and if you see my previous video, you will see that's not a good idea, because if the password change, now you have to remember all the systems that are using this password. So the password is real something that it's let's say permanent, and tokens usually you can find a way using these flows to say, okay, I'll generate this token just for this particular activity that takes half an hour. Then the token will be expired. If they need another to execute it again, they have to ask for another token. That's the main advantages of using OAuth2. And this is a reason for the existence of multiple flows. So let's see more about these flows. The first thing that you should understand is how to choose one of these 4 flows. It depends of 4 points that you should follow. One, who is making the request? It's a person, it's a machine. Second, can they handle secrets? Meaning, can I store a secret in me? Can I store a secret on this machine? For instance, you don't want to store a secret in a browser. So there is a specific flow for browsers. But for instance, if you are inside your company and you have one server that needs to connect to another server, and it's in your, let's say, behind the firewall, it's in a very safe place, then it's not a problem to keep a secret there. So it's a different flow. And is user present? Usually when there is a user present, you can ask for something. Username and password, maybe a code, something that a human can see or listen and use it. If there is no user, the system should handle things differently. Okay, and what type of app is this? So it's a mobile application, it's a browser, it's a machine. All of these 4 criteria will be used to choose the right flow. So let's see the flows. We have the first one, which is authorization code flow. It's the most popular one. It's usually related with a person. I will explain in a moment more details about this flow. The other one is client credentials flow. Usually there is a human, it's a more machine. You can keep a secret. Resource owner password flow. This one, you can ask for a token based on a username and password. You don't have to be in person there, but you have to have the username and password. That's why it's not safe, and most of the times when you read documentation about OAuth2, they say please avoid this flow, but sometimes it's necessary. And you have the device code flow. I have seen this one, and I'll explain the details later. For instance, when I wanted to configure a specific app to connect, for instance, to Google, like YouTube on your TV. So you have to prove that the TV, it's yours to the Google, but it will involve the TV, the Google, and you in person. So it's the device code flow. And then the fifth, it's not the flow per se, but that's something that happens usually in these flows. Most of the times you'll receive a refresh token, so you don't have to go through all the flow again when the token expires. If, for instance, on the first flow, it's quite common to receive a refresh token. On the third, also it's quite common to receive a refresh token. So you receive a token for 1 hour. When it expires, you can ask for another token just using this token. You have to keep this token, and you keep asking for new tokens using this refresh token. Okay, let's start with our first flow, which is the authorization code flow. It's designed for apps that can keep secrets. Okay, so you have an app that can keep a secret, meaning sensible information, and user is present. So if you have these two criteria, probably you want to use this authorization flow. The app gets authorization without getting your password. It will be, of course, using a token, and there is a strong separation of front end and back end, common for web plus mobile applications. When you have web application, mobile applications, usually you can use authorization flow. At the end of the day, you can, if you want a tip to remember this authorization flow, it's when you as a person, you can authenticate using username and password. For instance, when you go to a website and that website, you say, I want to enter on this website using my Google account. Probably that website is using this first authorization code flow. So what is the flow? The idea is that the user accesses a client app using the browser. So you want to access a client app, let's say it's Gmail to facilitate, or maybe a forum where you can authenticate with Google, for instance, and this client app will redirect you to the authorization server. In our case, it will be Google, and Google will ask, okay, what is your username and password? And sometimes it lists what the client application is trying to access. I gave an example in my previous video about OAuth2. For instance, you want to print some photos, and the Google asks, okay, this client app wants to access your Google Photos. Do you allow it? Or maybe you are accessing Gmail. This application is trying to access your emails. Do you allow it? Because Gmail belongs to Google, but the authorization server, it's not the email server. Your Gmail still needs to use an API, and that API needs a token generated by authorization server, which is the Google authorization server. So you provide the login, and you confirm that, okay, I consent about this access. And the authorization server then generates an authorization code and sends to your client app behind the scenes. Your client app receives this, usually a browser. You can see sometimes some redirects, and it will send a code after you receive this information and exchange this code plus other information that I will explain in my future videos. My next video, I will develop in practice this working so you can see how you can implement it in a specific, you can use something like Spring Boot, Node.js. I will choose one of them so you can understand how this works. But at the end of the day, it will send this code. You take this code, you send again to authorization server, and this authorization server receives this token and gives you now a real access token. And sometimes it adds a refresh token also. And this access token, now you can use this one to connect to your research server. And your research server can be an API to access Gmail. It can be the API that access to your Google Photos, or a backend that you want have in your company, and so on and so on. Behind the scenes, I will explain this later. The research service once in a while connects to authorization server to confirm that this token is valid. And if everything is okay, it will accept your authentication and returns to you data. You can see that this client app is accessing the research server, asking, calling the specific APIs without using your username and password. Your username and password was only used to connect to the Google, not the place where the data is. And after this login and password that you provided here, you will never to do it again, because everything will be about access tokens, unless you go to authorization server and say, please log out my user from all the resource servers that I'm connected to, where this client is accessed. It will invalidate the token for this client app in every place. So the next time there will be a request to this resource server, the request server will say something, okay, it's invalid, and probably your client application will show you again this login to the authorization server. That's probably the most popular flow that you will see when you are using OAuth in a specific system. Then there's the second flow, which is the client credentials flows. In this case, there is no user, probably a machine to machine, and the app authenticates as itself. So there is an application that will connect to a system, but it doesn't need a person. So it should have something, as you may guess. Let's see what this application should have. So use it for machine-to-machine communication, useful for backend services, cron jobs, API. Sometimes a cron job that runs, let's say, once in a while or every day at midnight 1 or 2 o'clock in the morning, and we should call APIs, get some information, do something with this information. And for this, sometimes it needs a token. Okay, it's simple, fast, secure, in trusted environments. So you want to use these in trusted environments, not outside. It's not for public. It's servers that you have in your company, and they are protected. So it's a trusted environment. If you have a trusted environment, you have no person involved, probably you want this second flow. So it's quite simple to understand. So you have a client ID and a client secret that I will explain into more detail in my next videos where we will be implementing one. But for now, when you have an application that wants to participate in OAuth2, you have to register that application on authorization server. If, for instance, if you go to GitHub, you can see there is a place there where you can register a client app, and it will ask you for a client ID and the client secret. And the client app here has the client ID and the client secret. That's why you need a trusted environment, because of this client secret. This client secret, for instance, it's not necessary on the first flow. You will only need the client ID if you, after we go into details about the parameters that are involved in all these calls. Usually the client ID, it's enough. But in this case, since you are in trusted environment, you can keep a client secret. And if you can keep a client secret, the flow will be simpler. So you provide this client ID and client secret. If you look behind the scenes, you can understand this is a kind of a username and password from this client. But this client ID and client secret was generated here on authorization, so he understands who this client is, and he trusts that this client secret was not shared with other applications. Otherwise, you have to go here and change the client secret or cancel this client application. If you cancel here, everything will be fine. So now you receive the access token, and now it's the same as the other flows. So you can call the API with this token to a research server and return the data. So it's quite simple, and it's like you have a username and password, but for your application. And you can say, okay, but what is the difference between this, okay, and have a regular username and password here? Again, you are not using a user, you are using a client ID and client secret. And again, it's about tokens. You can generate tokens for specific minutes. Remember that you are not using this client ID and client secret to connect to the research server, just to authenticate on authorization server to get a token. And then you keep using this token later. You don't use again the client ID and client secret. Sometimes people, when they see this flow, say, okay, this is the same as a username and password. It's not, because you remember that you authenticate on authorization server, and then you get things on a third party, which is the research server. So you go to authorization server asking for permission and a token to access another place. Remember that OAuth2, it's about doing things on your behalf. It's not doing things like as if you are doing. It's you are delegating authorization to an external, in this case, client application, to access this research server, but you want some mediation, a secure mediation from authorization server. Now you have the resource owner password. It's probably the lesser safest one here. You should avoid it, but sometimes it's necessary. For instance, sometimes I work in companies where I don't know the reason, sometimes maybe because it's the easiest one probably to implement, they use the resource owner password. So the user gives username and password to the app, not recommended for public or third-party apps, but they are used in public and third-party apps. Works when the app is fully trusted, mostly used in legacy systems or internal tools. Usually you see in legacy systems, and in my case, all the systems were legacy. So the idea is the user provides username and password to the client app. The client app sends the credential. It's not using the client ID and client secret. It's using username and password. Of course, behind the scenes, I can say to you that it will provide username and password to the client app. The client app will take username, the password, and the client ID here, because it needs to be a registered authorization server. These clients always have to be registered here, and all of them should provide a client ID all the time. So behind the things here, I didn't want to put all the details in this specific video. My future videos, I'll promise I'll show you all the details, but first I wanted for you to understand the flows and why they exist and how they work. Then we'll go through one by one and do an implementation, so you understand what is behind them and the why they exist and how to practice which one of them. So again, username, password. Behind the scene, there is a client ID that goes here and will authenticate here. So the authentication will be this username, the client ID, and this password. and you'll receive a token, usually again with a token that can expire and so on and so on. And then you can use this token to access research servers. Quite similar to this one somehow, but this for machine. And here you have a person that knows username and password. These username and password are not this client ID. The client are the application that is registered here, your mobile application, your backend service, and so on. Okay, here it's the person's username and password, and behind the scene there is a client ID here being sent to the authorization server. And then you receive the token and you can access the research server. Now you have the device code flow. Device code flow, it's usually, I have seen this used for access in TVs and consoles. So it created for device without keyboards. So the user logs in on a separate device. User is involved but indirectly, but it's involved, and the device polls for approval and avoids credentials input on untrusted screens. So how this works, let's see the flow, and then I will explain where you can see this. So you have a device, let's say a TV, and you have an application there that wants to access Google. Let's say something like that. So you have YouTube installed on your TV and you want to authenticate on YouTube, but you don't have a keyboard. So you only have the TV. So you cannot provide your username and password. So there is a device, and devices, there is a request for device and the user code. Usually the device will generate the code, let's say 17, something like that, and sends to the authorization server. And the authorization server says, okay, I understand what you are asking, so I will send you the device code and the verification address. And sometimes this verification address is a go to your YouTube application that you have in your mobile device and use this verification address. And then you go there. And when you open this address there, usually it opens a browser and you enter the code that was provided by authorization server. And then you have the code, the login, and the consent. Now the authorization server says, okay, so the user is answering to the request that I did here. So you receive now the access token here on the device, and again, you have the access token, you can access the resource. In this case, it will be the device, maybe your YouTube app now accepts your login because you did it here indirectly in a different place, not on a device. Remember, this was a TV without the keyboard, but now here you can authenticate. You can use keyboard, maybe it's a kind of face recognition, a pin or something on your mobile, but you can open the address. And then sometimes you can even see here a QR code that you can open with an image on your mobile application. That's the fourth flow that you can use on OAuth2. So you have this token and you access the research server as usual for the others. The fifth one, it's not a flow, but it's something to remember. Usually when you receive these access tokens, you receive also refresh token that you can use to continue to receive tokens after they expire. So it's used after a flow completes. It keeps sessions alive without asking the user again, because some of the flows need some intervention of the user. And in this way, when it expires, you can use the refresh token and you receive again a new token. It's only available to trusted flows like authorization code. It's not all the flows, only the ones that are trusted, the ones that we talk about, like machine, or when a user can present a username and password, and avoids login fatigue, supports long-term access. So the user doesn't have to constantly log in into the system. Now, if you will look into the relation between the authorization server, and now this one is a refresh. I was talking about this one. Sorry, guys. So you have this client application. This is a refresh. So you send a refresh token to the authorization server. You receive a new access token, and now use this token as usual. And if it expires, you can use again the refresh token, and so on, and so on, and so on. Now, there is a relation, of course, between resource server and authorization server, because most of the times we're seeing this, but we never see the resource server talking with authorization server. But of course, you have to talk. Usually, this resource server also works most of the times with a client ID. So sometimes you have a mobile application that contains a client ID, and the resource server also is registered on the authorization server on client ID. And behind the scenes, this is more advanced. I didn't want to introduce this, but I can explain to you. Behind the scenes, what happens is there is an attribute on the token that is called audience, meaning that when this token is generated in any flow, not on refresh, but any flow, when a token is generated, there is an attribute there, it's called audience. And you can say, okay, this token needs to connect to these resource servers. And you give it a name, and the authorization knows about it. So when this resource server receives the token, it takes this token and say, I am this guy, and I receive this token. What you want to say about this authorization server? And the authorization server, we say something, okay, it's valid or not. That's how it works. So you have this client app, request access token, you receive the token. Of course, behind this, you have the 4 different flows, but let's keep this simple. So now when you call the API with the token, the resource server will call for an introspection or key check on the authorization server. It doesn't have to go there all the time. It maybe can cache, but usually should go there and ask you, okay, I received this token, is it valid? And things that will be, it will be, if this token was generated by the authorization server, if this resource server is registered here, if the token is can be accepted by this resource server. Remember that you can have more than one resource server. You can have, for instance, Gmail, Google Docs, a lot of the different APIs, for instance, that you can have in Google. But when you generate this token, you could have said something, okay, this token, it's valid, for instance, for Google Photos and Gmail and Google Drive only. And okay, so when they receive this token, it will ask authorization server, can I use this? And the authorization, okay, you can use it. Yeah, this is correct. Else, okay, so we'll accept it. And it will give you token information, public key, and if it's okay or not. And now it will return the protected resource. So behind the scenes, I didn't put this on all the scenarios because it will be very repetitive. So I provided here in a final slide about the resource authorization server, how this works behind the scenes. I will provide now in my future videos how to implement this. So we will start on my next video. The first thing that we'll do, we'll go, for instance, to GitHub or other. I didn't decide yet what will be the single sign-on. GitHub, it's quite simple. You can create a client ID and a client secret, and then we implement one of the flows, and you will see this from 0 until you can implement. And if you understand for one of the flows, you will understand for all of them. The first one, it's the most complex one because everything is involved there. The user, the client, the resource server, research service. If you understand that one, you'll understand all the others. So why so many flows again? You have the authorization code, user is present. This is a table that you can follow to decide, just a summary of what we explained. So at the end of the day, it's always the criteria if the user is present or not. What is the type of the application that we have? It's trusted or not? It's in a confidential place or not? Meaning, can we store the secrets here or not? Usually when you are a trusted environment, you want flows where you have someone that can keep a secret, like a person or a machine in a trusted environment. Otherwise, you want the other flows. So in summary, OAuth2 isn't one flow, it's a toolbox. Each flow is optimized for a specific environment, and security depends on choosing the right one. And this is something that I really hope that you got from my explanations with these 4 types of flows. So I hope to see you in my next video, where we'll be starting to implement a real practice with code and servers running. I will try to do with less code possible, with something that you can install on your machine, something like that. I will try as minimal as possible, but usually this is a really architecture thing where you need at least 3 parties, usually a resource, authorization, and at least a client and the person, for instance, for the first one. So be ready to prepare your system for that. Probably use some Docker image or something to make this as simple as possible. So again, thank you for watching this video, and I hope to see you in my next videos.